Okay, let's go ahead and begin with chapter 3 and if statements. This is where you kind of really start doing real programming and, well, scripting. And this is where you start making decisions and working with your first control structure. Now, there's basically two types of control structures. There is if statements, and then there's what we call sequence structures, or not control structures that are if statements and looping. But before we get too far into it, let's kind of look at kind of some of the things that we're going to talk about today. And that is if else statement. You guys can work on the comparing strings and work in once we kind of figure out what an if is, you can start nesting your if statements. And then that's with one if statement inside of another if statement. And then we're going to go ahead and cover logical operators. And so that kind of comes down to these items right here, if, else, if, logical operators. And then we're going to have a little fun with some wild if statements. And that way we can also kind of cover a little bit on chapter 2 we haven't talked about, which is operator, precedence, and associativity. So let's go ahead and begin with if statements and what they are. And, whatever language that you're working with, when you're working with an if statement is a control structure. In fact, every control structure works with what we call Boolean values, so true or false. Now, so if you were to create a variable and assign it to true, that's a Boolean. It's actually capital T in Python. That's a Boolean value true. What it actually is when you're assigning something true, you're actually assigning it to the value 1. Or in some other languages, the value 2 can consider to be true, or 3, or any non-zero number will be considered true, but not in Python. And that would be something that would be a C level. But Python actually uses the true and false when actually all it is a 1 and a 0. So when I'm referring to true, know that I'm talking about a 1. When I'm referring to a false, know that I'm talking about a 0, but also the fact that it's true or false. But 1 and 0 is respectively is what is treated for your Boolean values at the lower level. So the if statement, that's all it's looking at is a true or false. And that's all it cares about. And that's kind of where I want to kind of get into simplifying if statements so that you really, really understand them. So when you have an if statement, basically you're changing the flow of your program. So the way your program works, top down, left to right, as it's progressing through your script, is part of the skill of programming that you're going to be developing. So the only thing that it cares about is true or false. And then we have to make sure that we tab in here so that what we're doing is treated in the if statement. So I'll give you an idea of what I'm talking about. So this is a traditional if-else. And notice how I have the if statement here, but I've tabbed in what we're supposed to do if the if statement is evaluated as true. Now I'm just directly putting true in here, but eventually I'm going to be using relational expressions to do that. So let's just look at it now and look at the behavior and look at how things are happening. So let's do this. Print after 2. But let me give you kind of an idea of what this indenting is for. After 1. Okay. So I'm going to set a breakpoint. We're just going to look at mechanics right now. Okay, so I'm going to set a breakpoint so that the program stops. I'm just going to throw in some value up here that we could start with. And then we can look at the evaluation of this if statement. And discuss it. So what I'm going to do is I'm going to start debugging. And my program is going to start at the very beginning. I'm going to do a step over. And you notice how it went in. It didn't need to evaluate it. It already knew it was true. So it just kind of skipped over it and went right into printing hello. Okay, but you saw that after, when I did another step over, the runtime goes all the way down to line 11. After 2. Well, why didn't this stuff print? Well, that's because that's the way the if statement works. When an if statement is true, it's going to output the stuff here. If it's false, it's going to do the else statement, and it'll output the stuff here. So the reason why it never got to that is because the else statement didn't hit. Now, if I change this to false, and we go to start debugging, I do a step over. It goes right, it evaluated as false, so it goes in and now it's doing the else statements. Okay. But why is it doing this line 11 print? Well, here's what happens with indenting. If I indent this in, it's no longer going to print because we've now put it under the else statement. And that's what your tab is for. It's what we call a scope. So the scope of this else statement is all 3 of these guys or these statements, unless I put this print off and not part of the else scope. So indenting is really important in Python. And it's actually one of the reasons why I kind of have issues with Python, because in other programming languages, they have a better denotation of the scoped areas. Like in C, you would have to put a curly brace here, and then you would put a curly brace after, and that denotes what statements actually belong. If I can actually get up here without this silly thing doing, okay. These curly braces would denote what actual code belongs in as part of that else statement. So that you don't have curly braces. You don't have this that other languages have. So you have your indents. So these guys indented after the else puts it inside the else scope. If this guy is back, it's no longer in the else scope, so it's going to run all the time. If it's put in the else scope, it's only going to run and print after 2 when the if statement is false. Okay, so let's look at it again in a little bit different way. Print after. Okay, so since this is false, this code isn't even going to run because that is tabbed in underneath the if statement. So it won't even run, but this one will because it's not part of the if statement. See? Okay, so that gives us with some kind of the mechanics of what if statements do. Let's go into how we trigger them, and we do that with what we call relational operations or relational operators. And these are operations that relate in some way. And you can look it up on the operator precedence and associativity chart here, which I'm going to bring up. And you can do it in any language. Like I'm doing the search for the C operator precedence and associativity, the C for the C programming language. Doesn't matter. They all have the same precedence and associativity rules for code. So whatever language you're working with, it doesn't matter. Precedence and associativity is universal. You learned it in grade school. Which do you add and subtract first on a line of code? So there are charts for precedence and associativity that we can use as part of our learning today and working through a few things. So we have in our associativity chart, we have our normal multiplication, divisions, and remainder, our plus and minus, and notice that multiplication and divide are in a higher precedence than addition and subtraction. What we're going to be using is we're going to be using these relational operators, these guys right here. Less than, equal, less than, greater than equal, equals to, not equals to. Those are all relational operators. Then we're going to be talking about this bitwise and the bitwise or logical or. Python actually uses the word and or. They don't use these symbols at all. So they use actually the word and or. So we'll be using that here in a little bit. So let's look at relational operators and just kind of get an idea for how they work. So what I can do is I can say, hey, if x is greater than 4, and let's go up here and let's assign x to 5. Okay, let's go ahead and run, start debugging. And here's a little cool thing that you can do in your watches. You can actually add a watch and just put in what x greater than 4 would be. What is x greater than 4? I have to do a step over before it pops up because x hasn't been created yet. So I do a step over and we say, oh, x is greater than 4, x has 5 in it. So you can examine what you're going for, and you can even just select lines of code to see how they evaluate. So this if statement, we know that is going to evaluate as true, and that's what the if statement is going to look at. Because remember, all the if statement cares about is true. Okay, so it went in and worked. Now what we can do is we can say x is equal to x greater than 4. No, that doesn't make sense. No, it doesn't. We can say x equals 5, and then we can say that a Boolean y equals to x greater than 4. And what that means is this is going to evaluate as true, and then it's going to take that evaluation and give it to y, so that we can just do y here if we wanted to. So now I'm going to go ahead and start my debugging. Okay, I created an x variable. Now I'm creating a y Boolean variable because when we use a relational operator, what the answer we get is a Boolean, true or false. Because relational operator just tells you yes or no. So in this case, we know that x greater than 4 evaluates as true. Therefore, y is going to have the value true, and therefore this statement gets all that it cares about, which is just a true or a false. Which is, hey, this is, some programmers would say, oh, that's stupid silly. Why don't we just put x greater than 4 in there and have it evaluate the answer to that. So x greater than 4 is done, then the true happens, and then the if statement looks at the true and runs, versus not running in an else statement. And remember, you're indenting for scope. And that's relational operators. So we can get a little crazy here. If we want to, we can do things like this. X is greater than 4 plus 4 divided by 2 times negative 12. What? Well, this is actually not that hard to figure out because we know that these operations are going to happen one at a time, and the x is greater than 4. If we look at the operator precedence and associativity, if I can bring that up again, we look at the less than, greater than, and you see that the times divide the plus and minus have a higher precedence than the relational operators. So that means that all these operations are going to happen first. And then if it's ever confused, like say you have two multiplications or divisions in one line, then it's going to do the one that's leftmost. So that's what we call left to right associativity. So let's practice that. Okay, so here we know this operation is going to happen last. So we can just kind of think about that as happening last. And I'm just talking about the greater than. Okay, what's going to actually happen is these values are going to make a change. And we see that we have a times negative 12, but we have a divided by 3. So this divide and this multiplication has a higher precedence than the plus or minus based on the chart. And since the divide and the multiplication has the same precedence, we evaluate it from left to right. So we start with this guy because of its associativity. So that means then that the first operation happening is 4 divided by 3. And I'm just going to bring up a calculator because I don't want to think this morning. We're going to do 4 divided by 3. Okay, 4 divided by 3. Okay, so this would become 1.33. And then the next operation happens, which is 1.33 times a negative 12. Well, duh. Well, okay, let's do that again. I guess we could just times it by 12 and multiply, or times it by 12 and carry the, so that's 16. Wow, I didn't even try to do that. Okay, that's negative 16. Okay, so negative 16 plus a negative 16. Okay, so then we take 4 plus a negative 16. No, this does not happen yet. This has to happen first. 4 plus a negative 16, well, duh, that's 8. Oh, no, that's a negative 8. Okay, now we got x is greater than or equal to negative 8. Is it? Yes, it is. So then your true happens. And then your code goes along and prints the hello and then does the next line. And that's how kind of if statements are evaluated with relational operators and when you kind of mix them up. But, you know, me, I'm always kind of like, you know, why do I have to figure it out in my head? Because, duh, I've got the best calculator in the world right now. And it's a programming language. There's nothing better than a programming language for calculating anything. I mean, you know, calculator is actually redundant. So what I can do here is I can just select that whole thing and say, oh, the heck with that. I'm just gonna go and add a watch for it. So I'll go over here to plus and I'll take this guy right here. I'm going to do a Control C, copy the text, go over here, Control V, put the expression in, and then I'll know. Okay, so evidently I can't hit the paste button. So something's going on there. Okay. There we go. There it is. Okay, x is greater than 4. Take out the parenthesis. And a value says true. All that hard work for nothing, but you got to know how it works. Because other than that, it's just stupid magic, and magic isn't going to help you. Because then you get stuck in the guess and check mode. And guess and check is the worst way to learn programming. I'm showing you the debugger for a reason, and that's because I want you to use it always for every program you build. Just get used to it. Okay, so let's get into the next thing, which is with if statements, and that is with logical operators. We're skipping a step. We need to get into if else ifs, and then we're going to I'm going to take a quick break and come back. So here is if else ifs. If else ifs are a special control structure where only one if will be actually happen. So what you can do is you can have something like this. If x, and let's go with this. Let's call this a grade. If grade is greater than 60. Now let's put grade at 80. We're going to print a D. And then we can do an else if, and it's called else if, all one word, Elif. Don't call it Elif, it's else if. And what we're going to do is we're going to be able to say, hey, is grade greater than 70? And if it is, tab in, print C. Don't do single quotes. Bad habits. Okay, and I've got to put my colon up here. And we can have our elif here, another elif. Grade is greater than 80. Print B. Okay, now and then here's the next else. The last one is where if none of these are caught, if none of these guys are caught, then the else will run by default. And this will be print, I don't know, let's just say F or whatever. Okay, so this is just it's kind of an addition, it's kind of just like an if statement, but what will happen is it'll check to see if grade is greater than 60. If it does not match this one, then it's going to go ahead and go down and match that one. Then it'll go down and it'll match that one. So let's look at how this behaves. And I'm going to start debugging. And I set grade equal to 80. And I say, hey, is grade greater than 60? Yes, it is. Print a D. But you're saying, hey, wait a minute. Mr. B, an 80 isn't a D. What are you doing, dude? And I'm doing it on purpose because I want you to see that the way that you build your control structures is important. Because you want to build it so that it flows in the proper order. So what I'm doing wrong here is if I'm doing this, I should start with greater than 80. And I should start with A or B. And then this one will be greater than 70 still, because that one would be C. But down here, we would do greater than 60. And then that would be our D. Okay, now let's look at how this behaves. And let's just test it out with 81. Because I should have been using greater than or equal to, but that's fine. I want to give you my point here, is that this is going to now run properly because we're doing things in the proper order. Now we get the B. So now let's test this with a 75 and see if it works. Because only one of the if-else ifs is going to actually trigger here. Okay. Grade is 75. Okay, it's not greater than 80. Oh, it's greater than 70. Print a C. Oh, everything works right, like it should. That's because your order is important also, and how you do things and which steps you take first for your programming. Okay, now that takes us into logical operators, and that is for when we want to do something other than this, because this is actually quite silly in some ways to do things this way. So we're going to actually do things a little bit different, and we're going to come back to this in shortly. So I'm going to do a full comment block here, which is just three double quotes around your whole thing, and we're going to get into logical operators. Okay, so logical operators work with an and an or. So, and it's all based on true and false. So when we use an and, we're saying a 1 and a 1 is equal to a 1. Because that's like saying if one is true and the other is true. So what we can do is if grade is greater than 80 and grade is less than, and let's do this right, let's do greater than or equal to, is less than or equal to 100. Oh wait, 90, 89, 89. Then we print B. Okay, so you see how that's different because we're actually putting a range of values in. And you see how it's much, in a lot of ways, it's much more controlled than the previous example that I gave you. Okay, so how does that AND work? What are the mechanics of the AND? Well, first, when you're dealing with logical operators, your relational operators are actually evaluated first. So the AND and the OR have different precedence than your... So you see here logical AND and logical OR are actually lower in precedence than your less than or greater than. But also notice here that your logical AND has a higher precedence than your logical OR. So what we're doing is we're taking and we're saying, hey, if this is true and that is true, then that means we meet the whole of it as true. So it's like this and that have to be true. Whereas the OR, it's just this or that has to be true for the whole thing to be true. So you can actually do it in a table. So remember, this has to be true and that has to be true with an AND statement for the whole thing to be true and run what's in the if statement. So what I'm going to do now is I'm going to just give you the table for ANDs. And that means, and remember, when I say a 1, I'm talking about true. So a true and a true is equal to a true. A true and a false is equal to a false because both of them have to be true. And remember, this is just my commenting and code with that with the hashtag or the pound sign. It's just so it's not code that I'm putting in there. It's just comments, just so you can get the table with on the same window of what we're working on. Okay, so we got 0 and 1 is equal to 0. And then the last logical, 0 and 0 equals 0. Okay, now let's do the ORs because the OR is kind of like the inverse and opposite of the ANDs. 1 or 1 equals 1. And 1 or 0 equals 1. So remember, only one or the other has to be true for the whole thing to be true. A 0 or a 1 equals 1. And then a 0 or a 0 equals to a 0. So you can see that we got 1, 0, 0, 0, 1, 1, 1, 0. They're kind of the inverse of each other. Okay, so now we know the truth table. So this is how we break it down then, is since the AND is not evaluated until your relational expression is evaluated, then that doesn't happen until those happen. So is grade greater than or equal to 80? Well, grade is 75 now, so that's going to be a 0. And is grade less than or equal to 89? And that's going to be a true because it is less than or equal to 89. So that's going to become a 1. And then after you do that, you've got your truth table for your logical operators. So a 0 and a 1 is a 0. So that's going to evaluate as false. Okay, so let's go cheat. I love cheating. I love to cheat. So, well, no, it's not cheating. But it's using it the way it should be used. So we can just look at it and see kind of what happens. We can also select each one or select the whole thing to put into our little watcher there here. And it looks like it's still on my clipboard from before. But anyways, you get the idea, because we can actually just take that whole thing and just say, hey, I want to know what that is. And before I run it, and it's still being a turd. For some reason, the insert keys and whatnot for copying, sometimes it just, Visual Studio Code just, like everything Microsoft, helps you too much. Okay, so, yeah, there it is. So I just put it directly in, and it comes out as false. So, but we already knew that because we went through it, and so it's just not gonna hit. Now we could do this, and we could say if and it will be Elif. I just told you not to pronounce it like Elif, didn't I? And then I just went and did it. Yes, I did. Oh my goodness. That is so awesome. No, it's not. Okay, so we're going to change this into continuing on with your else if. And what we're going to do is we're going to surround it, but this time we're going to change it to a C. And we're going to say, hey, is it greater than or equal to 70, but less than or equal to 79? And now, now this is going to work and work appropriately like it should, because grade is 75. Okay, we hit that one. Nope. This is where it's going to trip. Yep, we're good. Print C. Yay. Okay. So that's kind of the idea of logical operators. Now, we didn't get into the OR yet, but I said that we're going to have some wild if statements. Well, yeah, that's how we're going to end this video today, with a wild if statement, and we're going to look at the OR a little bit. So let's do this. Let's get a little crazy. Let's go ahead and just do stuff that I don't know what's going to happen. Okay, x equals, xy equals 3, c equals 1. Okay, wild if statement. Let's just worry about one if statement, and we don't need to get into any of that stuff because we already talked about it. So, wild. All right. We're going to say, hey, if x is greater than 2 plus y divided by 2, and y is less than -3 plus x times 2 divided by 2. No, that's stupid. Divided by 4. Or x plus y minus 2 is greater than, oh no, let's do less than this time. Less than 25. Okay, that is absolutely nuts. All right, let's take it down from the top. What happens first? And we're going to look at this whole statement, and we're going to think about operator precedence and associativity. Multiplication, times, divide, all happens before minus. So let's go. And which times divide happens first? Well, the leftmost, because we are dealing with our left to right associativity. Whenever we have a competing competing operators. So we're not going to do this divide first. We're going to go over here to the leftmost, and we're going to do this divide first. So what's y divided by 2? So 3 divided by 2 is 1.5. Okay? Then we go, oh, okay, what's next? Oh, 2 divided by 4. Oh, wait, nope. Leftmost, x times 2 happens first. Okay. Well, that's 4, isn't it? 2, x is 2, so that's 4. Okay, and do we have any others? Any other times of multiply? Yep, we have this one. 4 divided by 4 is 1. Okay, now we're done with times and multiply. What's the next thing down on operator precedence? We got to do we did our times and our multiply up here. We need to do now our plus and minus. So we're going to go ahead and do 2 plus 1.5 because it's leftmost, right, for our left to right associativity. So I'm going to do 2 plus 1.5. That's going to be 3.5. Then leftmost again, a negative 3 plus a 1. That's going to be a negative 2. And then we do, x plus y minus 2. Oh, that's kind of cool. Okay, x plus y. Okay, let's do 2 plus 3. That's 5. Then we do minus 2, and that's 3. Okay, are we to our relational expressions yet? Oh my goodness, that was so much work. All right, x is greater than 3.5. Remember, we start leftmost. Is x greater than 3.5? No, it's not. That would be a false. And then y is less than negative 2. That would be a false. And then or 3 is less than 25. That's a true. Okay, well, now we've got some real kind of wonky stuff here. Because now we got to decide what happens first. Do we do the and first, or do we do the or first? And then what we do is we look at our associativity chart, and it says, oh, the logical and is more important than the or. Okay, so a 0 and a 0 is a 0. Then we get into a 0 or a 1. Well, a 0 or a 1 is a 1. So that's a 1. So it's going to print out yes. And that's kind of, I mean, knowing these behind the scenes things is extremely important. Now, I know your book is going to, talk to you about some of the things that I haven't discussed, which is fine. That's fine. I want to get to the things that they don't really cover very well. So this is something that we can then take, and now that it's complete, let's cheat and start our debugging, and we can just go in and select it and put it in our examiner. I think it doesn't like me for some reason. Oh, it just put out yes. I didn't do start debug. I did do start. Oh, I didn't set a breakpoint. Silly goose. Okay. Run without, or start debugging. Here's my breakpoint. Okay, step over. Okay, I can select this whole thing, copy it, then add it to my watch, and I can see what the answer is. Oh, that is really interesting. It comes out as 3. Okay, so evidently it doesn't always work that way. Okay, well, evidently a non-zero is true, but there's no magic there. Something's going on weird there. That's not right, but that's okay. We can choose the little pieces if we want to see how they evaluate. I don't know. I may have just copied and pasted everything wrong. That's okay. But the debugger is something that you have to use. You have to use it. And I mean, literally, I mean, do you really want to have to be programming 4 hours a night for? I mean, I did it for years that way, but I didn't really, I didn't, I didn't have the resources that you guys have. And you guys have so many resources out there in the form of videos and in the form of tools that are readily available for you to play with. And of course, your compiler is the best calculator you will ever have, or your interpreter, or a programming language. So I encourage you to please set a breakpoint, step through your code, look at what's actually happening, examine it, visualize it, and that's where you start to develop your skill in programming. It's not by reading your book. It's by doing it. Alrighty, guys. Thank you.